All right, now we're going to look at those different trig ratios that come within special right triangles. So the first one is a 30, 60, 90 degree triangle. It says we're going to draw that. Remember, to draw a 30, 60, 90, you could start by having an equilateral triangle that's got sides of 2 and 2 and 2, and then just splitting it in half. And that's what I'm going to do here. We'll get rid of this side down here, and let's see, that would make this my 90 degree angle, my 60 degree angle, and my 30 degree angle. This is no longer a full side of 2, but we cut in half, so it's a side of 1, and then that's square root of 3. Okay. Label the sides of the triangles. We did that. Find the sine and cosine of the 30 degree angle. All right, so this is the angle that I'm keying in on. That's my theta, right? So I'm going to find the sine of that 30 degree angle, and I'm going to find the cosine of that 30 degree angle. Then we'll do the same thing with the 60 degree angle. Okay, so the sine of 30, sine, let's see, so, ka, toa. Maybe I should just write that up here. So, ka, toa. Sine is the opposite over the hypotenuse. Well, in this case, what is the opposite? Opposite of that angle is 1, and the hypotenuse is 2, and so therefore the sine of 30 degrees is 1/2. I don't really have any other simplification that I need to do with that. Okay, let's look at that same angle, but this time we're looking at the cosine. Here's the cosine. The cosine is the adjacent over the hypotenuse. Adjacent over hypotenuse. So the adjacent side going off that 30 degrees is the square root of 3. The hypotenuse hadn't really changed. That's 2. And so the cosine of 32 degrees, or excuse me, the cosine of 30 degrees is square root of 3 over 2. So I've got the sine and the cosine ratios of that specific angle. Now we're going to do the same thing, except we're going to look at this angle that's 60 degrees. And so I want to find the sine of 60 degrees, and I want to find the cosine of 60 degrees. Okay. The sine, like it was over here, is opposite over adjacent. The only difference is my opposite side is different because it's a different angle that I'm coming from. Opposite this angle is square root of 3. And the hypotenuse is 2. So the sine of 60 degrees is square root of 3 over 2, which is what we had over here. And that's one thing we looked at already. The opposite angles, not counting the 90 degree right angle, one angle's sine will be the other angle's cosine. One angle's cosine will be the other angle's sine. And so we're seeing that here, which makes me think that the cosine of 60 that we're going to solve for is probably going to be 1/2, right? Let's set it up and just double check. The cosine is adjacent over hypotenuse. And if I'm looking at this 60 degree angle, the adjacent side is 1. And the hypotenuse is 2. And sure enough, cosine of 60 degrees is 1/2, which is the same as the sine of the 30 degree angle. Okay, let's try the same thing with a 45, 45, 90 degree triangle. Okay, so if this is my triangle, 90 degrees down there, we'll call this 45 degrees in here and 45 degrees in here, which means those legs are the same. If we call this 1 and 1, remember the hypotenuse is the same as that leg times the square root of 2, so that would make this hypotenuse square root of 2. That's how we would draw that triangle, label the lengths, and now we're in a position where we can actually find the sine and the cosine of those angles. Okay, so let's find the sine and cosine of this 45 degree angle. Sine of 45 degrees, and then we'll find the cosine of that 45 degree angle. Remember, sine is opposite over hypotenuse. And in this case, the opposite side is 1, and the hypotenuse is the square root of 2. Now, I don't really like that radical in the denominator, so I'm going to multiply the top and bottom by square root of 2, which means square root of 2 over 2. That is the sine value of that 45-degree angle. If I do the cosine of that 45-degree angle, cosine is ca A over h. And in this case, the adjacent side is also 1, and the hypotenuse is still square root of 2. And when I simplify, it's just like what we saw up above. Whoops. Hold on just a second. That ends up being square root of 2 over 2. So in this case, for that 45-degree angle, our cosine and our sine are both the same value, the same ratio of square root of 2 over 2. Now let's take a look at the other 45-degree angle, and I want to find the sine value of that 45-degree angle, and I want to find the cosine of that 45-degree angle. And so if I look at the sine value, which again is up here, opposite over hypotenuse, the opposite side is 1. And the hypotenuse is the square root of 2, and when I simplify that, I get square root of 2 over 2. That should sound awfully familiar. And when I look at the cosine, which is adjacent over hypotenuse, I get the adjacent side here of 1 over the square root of 2. And again, when I simplify, I get square root of 2 over 2. And I'm hoping none of you are surprised that those are the exact same things, because like we said, even though it's a different 45-degree angle, in other words, it's in a different spot, it's still 45 degrees. The sine value of a 45-degree angle is always the same no matter what triangle it's in. The cosine value of a specific angle is always the same no matter what side it's in, because these values are based off of right triangles that are all similar and have the same ratios. Okay, so it doesn't matter if it's the sine or the cosine from this angle or this angle, that those two are going to be the same.